Well, welcome to the Factoring Polynomial Workshop. Amanda, right now we have, I think, just you in the session, but we may have some people joining us later. So this is a workshop. It's comprehensive in the sense that it's going to cover all the different factorings, the basic factorings of polynomials that you may have seen before and need some review on. The session will include examples that we're going to work, and one of the things to get full benefits of the workshop, it's important to have a pencil and paper in front of you handy so that you can work and try some of the examples for yourself and see if you have any questions on how to factor these things, okay? Now, if this is your first look at factoring, the workshop may not be as beneficial to you as if you've actually done some factoring already or you're doing it in class, because we are going to do a review of all the different types of factorings one can get into, okay? So to kind of give you the heads up. Okay, so elementary algebra, okay, good. If you're working in elementary algebra, you are probably, if not already, involved in factoring things. So this will be a good workshop, I think, to kind of reinforce that and go over that again, because we're going to start right at the beginning. And yep, now to start, that's perfect. Last week. Okay, so you started you've been introduced then probably to the idea of a polynomial, but really, that's one of the things that we really want to define nicely so that you know what you're looking at. You know when you're looking at one of these creatures, these polynomial things. So we start with the basics. A monomial. Mono means one. So one of these things is really a set of things multiplied together. So this is c times x raised to some power. Now we can have a bunch of things multiplied together here. As long as it's all multiplication, that's what we call a monomial. One thing involved with a bunch of factors. Factors are things that are multiplied. So that's one of the, whoops, that's me assuming it, sorry. So that's one of the things that we want to get comfortable with, is this idea of the vocabulary. And this is in red, sorry. So this monomial is involved with with factors, things multiplied. All right. And for example, here's an example of something that we could have as a monomial. Let me pick another color besides red because I don't like too much red. So let's say we had something like 3x to the fifth. This is definitely an example of a monomial. It's 3 times x raised to the fifth power. Another thing that identifies a monomial, or one of these things that make a polynomial, many of these monomials add together or subtract from one another to make a many-nomial thing. So 3x to the fifth. Well, what's important is that n must be a whole number. In other words, it has to be 0 or a counting number. So it has to be in the set of things such as 0, 1, 2, etc. So that n cannot be anything other than these whole numbers. If it is, then this creature is not a monomial. Okay? So for example, if I had something, this is a monomial. Here's another example of a monomial. 4x, y to the 4xy is a good example. That's 4 times x. Now, if I don't write anything up there, remember that's to the first power, and y is to the first power. So the exponent is a whole number, and it's just a set or series of multiplications there, 4 times x times y. So these are monomials. If I put them together, I could form binomials, which means 2 terms. For example, I could put this together, such as 3x to the fifth plus another monomial, 4xy, and I've got what are called 2 terms. Terms are things that are added or subtracted. So there would be one term. There's the second term. And let me write that down. Terms are things that are added or subtracted. Okay, so that's some of the vocabulary that we're going to be using. When we talk about terms, we're talking about things that are added or subtracted. When we talk about factors, we're going to talk about things, numbers, and variables that are multiplied. Okay. So this one, as I said, is called a binomial because it has two terms. So this would be a binomial. Okay. And so that's the idea with these things. If we wanted to form a trinomial, we would, of course, have three terms. And I'm going to put a trinomial, or you can think of one. Let me put the word trinomial down here for a minute. And then just imagine for yourself what it would look like. And then I'll put one down and see if your guess was right. Trinomial means we have three things that we're adding or subtracting. So an example might look like this. Might look like something like x. Now the exponent has to be a whole number, so I'll put x squared maybe. There's one monomial. There's another one here. This is going to be 5x. And maybe plus 6. So notice we have 1, 2, 3. We have three terms. So this thing is called a trinomial. Tri for 3. 1, 2, 3. And notice those terms are all different. I mean, one of the things you do in algebra is collect like terms. So, you know, in your algebra class, you discovered what like terms are. And you can see that each of these terms, these are not like terms. X squared cannot be combined with 5x, you know, by just adding. So these two terms have to be left the way they're written. So these are three distinct terms that we've put together to form a polynomial that we call a trinomial. Now, you can imagine we could put four terms together and 5 terms or 6 terms. And that's where the poly comes in. Poly means many. So for polynomials, we mean many terms. And it's just a general term to stand for, you know, however many of these we want to put together. So for the first one, we've got a monomial, one term. Binomial, of course, is 2 terms. And trinomial is for 3 terms. And these are pretty much the only ones we're going to concern ourselves with. Now, one of the things that we can also use to characterize these polynomials is the degree, or to what power, the greatest power, these polynomials are to. And so for this trinomial, we can see it's to the second power. So sometimes we'll call that the second degree trinomial. So if you're into that naming, or if you've done that in your work already, that's where they come up with that. They look at the degree of the polynomial, in other words, the exponent, and that's how they get the degree. So this is a second degree trinomial. Second degree because the highest power, the exponent to the highest value, is 2. This binomial right here would be to the highest power is 5. Since I have 2 variables here, this degree would be 2, believe it or not, 1 plus 1. But this degree for the highest power, this would be a 5th degree binomial. Okay? So that's where that word degree comes from. Okay. I'm going to move on to actually do something with these. We're going to do the opposite of factoring. Okay, so I don't want to, you know, you've already maybe seen the naming of these polynomials. You know what they are, kind of now. Let's do some operations on them. Let's multiply them and see how to do that. Now, the reason I'm picking only multiplication is because when we do factoring, it's the reverse kind of multiplication. So factoring, we're going to think of as the reverse of multiplying. And from your experience, I think probably you've been able to multiply these, quite nicely. And when we multiply something like this first one, we have a name for it. Amanda, do you know what it's called when we have a number outside and we multiply everything inside? You know what that's called? You can type it in the chat if you do. So if you were thinking that, I might have beat you to it if you were ready to type it. But that's called distribution, okay? So we take that factor outside. Okay, great. We take that factor outside and we multiply or distribute it to each thing inside. So for example, the answer to this one is going to be then just that multiplication of negative 3 times 2x, which will give us negative 6x. And negative 3 times negative 5. And if we think of that subtraction as adding a negative, that'll give us positive 15. So that kind of distribution is we know how to do. So we can take a monomial. Remember that negative 3 out in front is really a monomial times a binomial. Okay, so a monomial times a binomial gives us negative 6 plus 15. Another binomial in this case. Okay, so the next one, we're going to do that one also. So you might want to try these on your own on a piece of paper that I suggested you have at the beginning. And there we go. So 5x times 4x, that monomial times the first term of the binomial. Then that monomial 5x times the second term of the binomial. And once again, we multiply them a piece at a time. And we should come up with our answer. So like I said, try to beat me to it and then double check my work that I'm not making a mistake as I go along here. I wonder if we've got a raise to. Well, this will be interesting. Well, we don't. That's okay. I'll do it by hand. All right. This is going to give us 20x squared. And my mouse work here, I'm using a mouse to write this, so hopefully it's not going to be too sloppy. 5x times this negative. That negative goes with the term that follows there when you're thinking of this distribution. So that's going to be negative 35x. Okay. So there we go. So multiplication, straightforward. It gave us a binomial of second degree. The exponent is to the second degree. The binomial for the original was to the first degree. So we multiplied through. All right, and we just repeat that. We just repeat that, that if we have a monomial outside in front of it, we just do it. So down C, give that a try yourself, and I'll give you a head start. But hopefully you get the same thing I do. And remember what this is. This is kind of practice before we actually get into doing the factoring. We want to know how to walk forward before we start walking backwards. In other words, doing the opposite of multiplying. This is going to be minus. Minus now, remember, that's a negative 4 times positive 3. We did that one. So that's going to give me a negative 12. Okay. And I could be done now, except look, I've got like terms. And from your algebra that you've already practiced, we have to simplify expressions that have like terms. So we're going to combine anything that's alike. In other words, the variables are to the same degree. Or maybe you have constants like negative 12 and some other number. In this case, we don't. Added or subtracted. So in this case, then, when we combine our like terms, we get 2x squared minus 18x minus 12. Okay. So So there you go. This is just multiplication. Now on to the nice part. We're going to run into probably our most challenging, and you may have done that already in your class. Challenging 20x squared minus 35 x. Don't forget the x on that 35x that you had up there, Amanda, in the chat. I noticed. So this x up here should have been in your answer. Oops. Sorry for the zoom. It's my mouse. It's my mouse. It's not me. So, okay. So good. And yep. And there is there's a trinomial that we just formed from that one that we just multiplied. Now we get into the interesting ones here. And your instructor, or when you work these in class, they may have used this acronym FOIL for when you have two binomials that you're multiplying together. FOIL, which stands for first, outer, inner, last. But, we don't need this acronym because we know we're just going to distribute everything with everything. Okay, but just if you were introduced to this mnemonic, here's what's going on with it. We're going to look at the first times the first, and that kind of helps you keep things organized, which gives us 3x times x. That's 3x times x is x squared. Okay. O means outer, so that means I'm going to take the outer ones, the ones on the outside of the parentheses. And so that'd be 3x minus 3, which is negative 9x. And then the inners, which would be the 2 on the inside, which is 2 times x. And they're both positive, so that's plus 2x. We're turning it into a term. Okay. And then, of course, the last. And that's the last one times the last one, which gives us negative 6 if I haven't made a mistake anywhere. And once again, we want to collect like terms, or we want to find the terms, the 4 terms that I have now, 1, 2, 3, 4, I want to write them together. So that's 10x. Which one is that now? Negative 10 minus 6. Well, let's think about this. Careful now. That 3x squared is different. Here's my like terms. These are the ones that have the variable to the same power, you see? So those are the only two I'm allowed to add together. That 3x squared has to stand by itself, because there's no other squared terms anywhere. X to squared, no. So this is going to be negative 9 plus 2. Negative 9, positive 2 still gives me a debt of negative 7x. Okay. So those two combine together to give me negative 7x. And then this number term, this constant term, has no one to combine with either. So you just leave it alone. So this is what it should look like when you're done. Okay, Amanda? All right, I'm going to give you a head start. Let's go ahead and do the last one. I'll give you a head start on your paper at home. Go ahead, just jot it down what you think it is. I'll give you a few minutes, and then I'm going to rip through it and see what I got. I'm going to try to use this FOIL method like I did before and see what happens. Now, just be careful. It might be a little bit different. And when you think you got it, go ahead and type yours in if you want to. Okay, I think you're on the right track. Yeah, let's see if mine, when I'm finished, mine actually matches yours. And then I've got negative 9. Now 3x and 3 gives me negative 9x. You may have forgotten that x on the end again. But remember, when you have, let me make that in red. When you do that 3x And 3, that's going to be 3 times 3 is 9, but then there's an x with it. So don't forget that x that goes with it. Okay, missed the x. Yep, good. Okay. And there we've got how many terms? 1, 2, 3, 4 terms. Now remember, the last thing I have to do is go back and see if any of these match. Are there any like terms? I think you have some like terms too. There's 12x, perfect. But then that last term had an x in it too. So these two are like terms. We have to combine them together to simplify. So that's what I'm going to do next. That's going to give me something like 3x, positive 3x, plus 18, which is what you had. Good, good. And minus 6x squared. And the nice thing about this is it ended up in such a weird manner right there that it gives me the opportunity to let you know that we don't like writing it like this. This is fine as an answer. Your instructor would probably give you credit unless he told you to put it in, or he or she told you to put it in descending order. And that means we always like the one with the highest degree first. We write that first. So that would be our first term. And this is just convention. All of the mathematicians kind of agreed that this is a good way to organize things. And then we write the next term, which had an x to the first power next. So we just put them in what's called descending order. So if you hear that word or that phrase, descending order, this is what they're talking about. And then just the number by itself, we write third. So there that is, and we did do E up here. So you might want to jot that down on your paper and try it for yourself. But what we've done is multiplied these. We've multiplied polynomials. And of course, that's not what our workshop is about, but it's good to spend this time because now we're going to talk about factoring. Okay. Any questions with this? Let me write the answers to this one down up here real quick so that you at least have it. And then we're going to look at factoring. So for E up here, the answer is going to be 15x squared. Minus 20 minus 3 is minus 23x. Notice I'm not working it. I'm just jotting down the answer. And then plus 4. Double check my arithmetic, but I think that should be the answer for E if you tried it already. All right. Let's get into the meat of factoring. Now, this is a real review session. I know we spent maybe 20 minutes with the first part, but it's going to pay off because now when we factor, we do what we just did in reverse. So if you kind of feel good about what we did, this is going to be a little easier. Okay. Now notice I've listed these in 4 different categories here. This first one you should always keep in mind. The GCF. Now that GCF of course stands for greatest common factor. Okay. And the greatest common factor is just the largest factor. Now remember what factors are. Factors are things that are multiplied. So the largest factor that every term in the expression has in common, that would be the greatest common factor. And this thing, you need a big exclamation point here because you should always keep an eye out for that. And that's your first step also in anything you do. Okay. So in this example they've given you, for example, 12x to the fourth, 6x to the third, and I'm going to try to blow this up if I can a little bit, right? Oops, there it is. 4x to the fourth, or 12x to the fourth, minus 6x to the third, plus 3x squared. And if I look at those 3 terms, here's the way you go about it. You look at the numerical values first. 12, 6, 3, and you ask yourself, is there any number that would divide into those, and all of those? For example, what divides into 12, 6, and 3? Well, the answer would be 3. 3 is the only thing that's in common. Yep, exactly. And let's take a look at the variables in this case. what is the largest thing that I could divide out of this in terms of x? Would I divide out x to the fourth out of everything, or x to the second power? What do you think? Yes, exactly, Amanda. So that's the GCF. The GCF in this case is just simply going to be 3x squared, because that's the largest factor that each of those three monomials has in common. Okay, so 3 is the greatest numerical factor. X squared is the greatest. If you tried something larger than x squared, well, it would not divide into that last term. That's why we pick the exponent, that's in common, but the smallest choice. All right. So now down here, we've got another one, and we're going to factor it this time. We're not just picking the GCF, we're factoring. But factoring means just bringing that GCF out in front and seeing what's left over, okay, and multiplying it through. So to factor this number I have down here that we just looked at, basically, there it is, 12x to the fourth, we put our GCF out in front, okay, that goes into everything, but we divided it out of everything. And when you divide 3x squared out of 12x to the fourth, you're left with 4x squared. When you divide 3x squared out of 6x to the third, you're left with 2x minus 2x. And then, of course, when you divide it out of 3x squared, you're left with 1. Many students forget to put that 1 there. Now, if you want to check to see if you did it right, of course, multiply it back through, and you should get what you started with. Whoops. You should get what you started with over here, okay? And so that's what you should always do once you factor is, if you want a quick check, just multiply it back through. All right, so this is one for us to try here. And if you've got an answer for that, now notice they said factor it, so we want it written something like this. What would be that factored? How would you, what's the GCF in other words? Put that out in front. 5y, I agree. And then what's left over once you bring that 5y, that greatest common factor out front? What's left inside the parentheses? Yep. Actually, I think we need one more y here. Remember, we divided only one y out, and this is y cubed. So we have 2, or y squared, left over. Is that okay? So careful with that. And notice the second one here, we divided out 5. When you divide out by 5, you've got 2, like you said. Okay, so there's 2. Come on, my mouse is acting silly again. There it is. Okay, so there's 2. And remember, we divided out the y, so it's no longer there either, okay? So that should be just 2y left over, not 2x. Oh, sorry. I said it the wrong way. We got rid of the y, so we should have 2x left over. Where's my eraser? Eraser, let me get an eraser. There is no eraser. Oh, well, we'll just make that into an x. There. Okay. So when you do these, yeah, it can get confusing there. But remember, just to double check, and I like to do this, I mentally double check. I multiply it back and see if if that works. Now, when you multiplied yours back in, you would find that you'd get 15y times y is y squared. So you know that there is something wrong because it's y to the third. So when you divide 1 out, you're left with 2 behind, okay? You're left y squared behind. So every time you divide out a variable, it's no longer in what's in parentheses, okay? That kind of makes sense. And as I said, we can always double check by distributing it back through. And if we made a mistake, it'll be obvious that we made a mistake. So always double check if this is something that causes you trouble. Okay? All right. So that was kind of what we're dealing with for the first step. That was only the first. Now remember, the 3 other steps in below were just 2 terms. We're going to learn to factor 2 terms. You know, that's a binomial. And then we're going to take a look at a 4 terms, which is a quadrinomial, I suppose you could call it, but we really just call anything more than 3 usually polynomials. So we'll talk about a 4-term polynomial, and then we'll get to the good one, the trinomial, and we're perfectly timed here. We're going to be going to 2, so this is a good place to be right now. All right, so our first one is the special cases, and man, you really do want to put these to memory. These special cases will make your life easier, believe it or not, if you identify them and put them to memory. Well, the first thing you're going to know about this special case is that it's for 2 terms. So that means something that looks like this. And I'm just going to give you an example, that maybe of one that we're going to do later. But for example, here's a term, x squared minus 4. Is an example of 2 terms. That's a binomial, like just a refresher. So you can see a binomial they give as a formula, just something squared minus something squared for this special term we call difference of squares. And it has everything that you have to remember about this type of special case. First of all, it's made up of squares. And of course, difference means we subtract them. So that's telling you exactly what the thing looks like, difference of squares. All right? So if you got something squared minus something squared, you have met this category. It's called the difference of squares. That's our test. First and last terms must be perfect squares. That means something times itself. And for our example, you can see that it's x squared, x times x, for a variable perfect square. And then this 4 is really just 2 times 2. So basically, we have x squared minus something else squared. That's 2. That's its root. Squared gives me the 4. So yes, it's a perfect square. And there's a subtraction. So it fits this category. And notice in this case, if we use this form, a in this one that I just did up here, a is represented by just x. So wherever we see an a, we're going to turn it into an x. We're going to replace our a with x. And you can see that would be x squared. Wherever you see a b, we're going to replace it with a 2. And you can see that 2 squared then is just going to give us our 4. Okay? So that would be a squared, which is x squared, minus 2 squared, which is 4. And here it is. And this is why it's so nice, because if it's in this form, we don't have to do any work. The answer to that factor then, if you wanted to factor this, if somebody told me to factor this, I know the factor is going to be a plus b, a minus b. So here are the factors. Man, I'm running out of room here because I'm throwing it in, but that's okay. So it's going to be a plus b times a minus b. And so this factors into that. That's my factor. So this binomial factors into 2 binomials. And I don't know, Amanda, if you've got to these special cases yet, but these are very important. If you haven't, these are used quite a bit, especially on what's coming up later that you'll have to do. But that's it for this special case. Now, there is one thing that you should note here, and I'll see if I can zoom here without going crazy. There it is. This right here is a special thing to note, because once again, this will save you work. If you have something squared plus something squared, notice there's nothing you can do with it. That's, of course, f. You've already collected out your greatest common factor. So we should always look for a GCF first. And then if we have something squared plus something squared, we call it prime, which really means we can't do anything. So if you got that on a test, you're happy. If you got that on the test, you just say it's prime and you go on to your next problem. Okay, so keep an eye out for that for the special cases. All right, let's do the example. This is going to be, let's see if I can blow it up just a little bit so I can see it this time. Oops, that's good enough. All right, there, okay. So that's a 9x squared minus 16. So test it first. Let's see what is being squared to get that first term. Is there something times something that gives me 9x squared? 3, yep. And what about x times x? So it's not just 3, it's 3x, okay? Because we also want to keep the variable involved. So 3x times 3x gives me 9x squared. And you're getting a feel. I know you had questions about those exponents and how those things multiply together. But those two x's multiplied together, of course, mean x squared. If you have 3 x's multiplied together, it's x to the third, etc. Okay? So that's our A. What would B be? What times what gives you this? 8 times 8 is 64. That's not right. Nope. 8 times 8 is 64. Now it has to multiply. Remember, something times itself. 8 times 8 is not it. Whoops, what the heck is that? It's 4. 4 times 4 is 16. Okay. Now that's another common mistake that students make. So you're not alone, Amanda, in thinking this was 8. Okay, so so don't feel bad about picking 8. But remember, it has to be something times itself that gives you 16. And that would be 4 times 4 gives me 16, not 8 times 8. Okay, and it's positive, okay, because I just want to know 16. The subtraction itself is part of the difference. So all I needed to know is what squares to give me just the 16 and what squares to give me this. Okay, and I've got it. And then I just write my answer down. The answer is going to be this, A plus B. Of course, we're going to substitute in what A and B are, but let me write it for a minute. So this is what our formula is telling us to do. So I'm going to take A, which is 3x, replace the A with what it is, plus 4. Notice that's why I didn't want negatives for my 4. I just want the absolute value that's positive. And then the 3x minus 4. So it's a plus-minus dance, I think of. When I think of difference of cubes, I know I'm going to have two binomials multiplied together, and one's going to be something plus something, something minus something. And that A and B come from the roots of these perfect squares that make up the thing we're trying to factor. Okay, so that's the special case called the difference of squares. And it's worth remembering or going back and reviewing in your notes in your book and put that to memory. You would be using this quite a bit. And I'm telling you this from experience, but this is a good one to put to memory. Okay. Now, the one down here is called difference of cubes, and I'm just going to go over this quickly, but this is another special case for two terms. And in this case, instead of square things, we're going to have cube things that once again fit a nice formula, okay? And this one, sometimes you put the memory if the instructor says you're going to be responsible for knowing this, and sometimes you don't. You just know that if you've got difference or sums of cubes, they can definitely be factored. They're not prime. They can be factored into something, okay? So let's see what we mean by the difference in sum of cubes, and then we'll look at an example. But once again, this one's important, but this one up here is probably the one you really want to put to memory, that one on top. Okay, Dave. There, that's a little better, I guess. So you can see we have something cubed right here, minus something cubed, and it factors into this formula over here once we identify what A and B are. This sum of cubes, something cubed plus something cubed, has this formula down here. Now, I use it quite a bit, so I've memorized it. The tests are the same, though. We got to make sure that there's perfect cubes, and we have to know whether it's subtracted or added. So I'm going to work this example. This is something times itself must give me 27. So I'm just going to go, let's say 2 times 2 times 2 would not be it. 2 times 2 times 2 is 8. That's not it. Let's try this one. 3 times 3 times 3. That's it. 3 times 3 is 9. 3 times 9 is 27. So this first one is going to be 3 x times x times x. X is the thing that you're going to multiply by itself. And that's what's being cubed. And we already said that 2 times 2 times 2 is 8, so that's going to be what's being cubed for this one. It's going to be 2 times 2 times 2. And that's what's cubed here. So when I write this down, A is basically going to be this thing in here, the 3x. And B is going to be this thing in here. In our formula is what I'm talking about. Now back up to that so you can see. And that's going to be 2. Now that formula, of course, is the one we had right here. This is the one for addition right down here. I'm going to get out of red in a minute here, but I'm going to write this over on the other side so we can see it. And the formula looks like this. If you've got addition, it factors into this, A plus B times a trinomial. It's going to be whatever A is, we're going to square it. Then we're going to subtract A times B. This is getting complicated, but like I said, you'll have experience before you're asked to use this, maybe some homework exercises to give you some more experience than you're going to get in this workshop, by the way. Okay. But there's our factor. That's what we're trying to use that formula to find the factor of a sum of cubes. There it is. And so when I put my A, B, and C in there, or my A and B, not my C, I've got 3x plus 2 plus B, which is 2, times A squared, which is 3x times 3x is going to be 9x squared, minus A times B, which is 3x times 2. And, yeah, bear with me. And B squared, which is 4. I just wanted you to see one of these, okay, actually being used, this difference of cubes, or sum of cubes. In this case, it's the sum of cubes. And then, of course, we could do the same thing with this one right here. But I'm going to leave that one, and you can copy it down and practice yourself if you want. But I'm going to leave that one for now, because I want to move on to something that's going to help us with darn trinomials, which you may be doing now and struggling with. But trinomials are something that a lot of people run into when they do their algebra class, and it's kind of a rite of passage. In other words, you will probably not be able to get out of your class, your college algebra class, unless you really learn how to factor. That's one of the things that is important for your class, is to learn how to factor, and of course to solve equations. So those two things sorry, did you say elementary algebra, right? You said elementary, yeah, not college algebra. Elementary algebra, you want to learn how to factor, which is what we're doing, and of course solving equations. Those are two big things for your class. All right. This is cool. This is the big one now, factoring by grouping, because if we can learn this technique, we can factor trinomials like there's no tomorrow. We can do it very nicely. So we're going to factor by grouping 4 terms. And this is all you got to do. Well, it can be more complicated, but for these basic examples, this is all you have to do, is to group it into 2 parts. Group it in pairs. So I pick the first pair. I pick the second pair, And you're pretty good, Amanda, at GCFs, or finding the greatest common factor. So take a look at that thing I underlined in blue, and can you tell me what the greatest common factor for 2ax minus 3ay is? What is a GCF for that, or the greatest common factor? Yes, thank you. 3a, beautiful. And remember, you got to practice what's left over too. So what's left over then is x. Yep, I'll let you do it. Yeah, for the first one. And remember, you need a minus in between, because don't throw that connector away. There's a subtraction in the middle there. Make sure you have that connector there, okay? Come on, mouse, settle down. Okay. Right. Now, the second one you're right too. There is a, two, what do you have for the second one? 2b. Okay, yes, thanks. 2b. And here's what you want to do. Notice this is a subtraction here. If that first pair is connected to the second pair by a subtraction, throw that connector out. So make it a minus whatever the common GCF is. So if it's connected by a subtraction, pull that subtraction out front along with your GCF, or GC, greatest common factor, GCF, which you said was going to be, come on, I have a Mac, so I have one of those smart mice, supposedly, but sometimes he's not too smart. Okay, and that's going to leave me with, notice the opposite of negative is a positive x, and this is where often mistakes are made too. Okay, and the reason mistakes are made, because when you pull that negative out, you got to make things their opposite. So, and I'm going to double check just to be sure. Negative 2b times x, positive x, gives me a negative 2bx. Negative 2b times a negative gives me a positive 2by. So it's working. So I've got the correct thing. I noticed something in particular with these two. Notice that the binomials that I have in parentheses match. And that's important. If this is going to work properly, those two things better match. And so x minus y matches x minus y. And if you look at that carefully, basically what I have is two big terms, this thing here and this thing here, and they've got a common binomial term. X minus y is common to both of them. So if I'm going to write that down, I just write that thing that matches down in front by itself. Times whatever's left over. So once I divide these out, notice that I'm left with this binomial. And so those four terms up there factored into product of two binomials. Okay, so that's how we factor these four-termed expressions. And as I said, these are important because they'll help us with trinomials when we come to it. So I'm going to do the next one as an example, and it's going to be worth our while to spend some time doing these. So I'm going to look at the first two terms, split it up first, second two terms, and then as I'm doing this, of course, on your own paper, think about what it's going to be. So the first one's going to be 4x. I'll give you a head start if you like. And that's going to leave me with an x, since I took just one x out, or divided it out, I left with an x. 4 sevens is 28. It's x minus 7. Notice you're left with a binomial, two terms. This one has a plus connecting it. See that plus right there? I put a plus down. Whatever's connecting it, that's what we want to put down in front. This one has a common factor of 3. The blue one has a common factor of 3x minus 21 is 3. And notice that inside my parentheses again, I have x minus 7. So as long as these match, I've done it in a proper way that it's going to factor nicely. Now, if they don't match, you either made a mistake or maybe it's not going to factor using the grouping method here. Okay, you might have to reevaluate and do something. But if they match, you know you're on the right track, and that's going to be one of your possible answers, one of your binomial factors. So there's my factors now. When it says factor that, and what's left over then, of course, after you factor, remember factoring in this case is dividing out the thing that's multiplied. You're left with 4x plus, that connector has to be there, 4x plus 3. Plus 3. And this now is factored. Okay. And we're in good shape. Okay. Okay. And we do have about, this is perfect timing, 10 minutes. I wish I had a half hour for this last one because these trinomials, of course, are the things that are challenging. What I'm going to do, just to kind of save us time, is of course, if you have questions with these special case perfect squares, these take up a bit of time to talk about on their own. So I'm going to leave that for you to explore and maybe get a tutoring session set up with one of the tutors on BrainFuse if you really want to explore that. And come and talk to me. I've got sessions that you can come in on BrainFuse and do your tutoring sessions. If you haven't been there yet, you want to maybe get signed in because it's a good place to get help. All right, I'm going to do this one down here though. I'm going to do B, and this kind of example with a trinomial and C are going to finish up our workshop for today. We might go over just a little bit, but not too much past 2. And you can see the example. These are trinomials, so that means we're dealing with something with 1, 2, 3 terms. We know tri means 3. So when it has 3 terms, 3 distinct terms that are not like terms, they're different. Come on, there you go. Okay. So in this case, we have 3 terms that we're looking at. We can maybe factor it. Now remember, I said maybe because sometimes you cannot factor. And we're looking at a case now where the lead, remember if we put them in descending order, the highest degree, second highest degree, and then your number, we put them in that descending order, and that first term has a number in front of it. Well, it doesn't. If it doesn't have a number in front of it, remember when we're dealing with algebra, that's kind of an imaginary one there. So that's what we're talking about. And that's called a coefficient. So we'd call that number in front of a variable a coefficient. Okay, my spelling is kind of crappy, but I think I'm close. So coefficient is basically that number in front of, whoops, that number in front of each of the variables. So that would be 1 in front of that one. -1 would be in front of the x. And then, of course, my constant term would be -12. So that's just some of the language. So whenever we have a lead term of 1, this factor is really nice. Now, here's our goal. Our goal is to get this thing factored, which means that we're going to end up with 2 binomials that will FOIL together to give me this trinomial. So once again, we're working in reverse. We're trying to find something that when you FOIL it with something else, another binomial, it gives you this one up here. That's what I'm trying to do. So this down here would be my factor. Okay, so that's what I'm trying. I don't know what it is. Okay. Well, here's what, this is a nice thing to do. We're going to do what's called the A times C method. Okay, and you can see up here what I mean by A, B, and C. A is the number in front of the x squared, B is the number in front of the x, and C is the constant term. So when I say A times C, I mean this number, which we said is invisible. It's not imaginary, it's invisible, I guess. But we know it's 1 times this number, and I always take the negative with it. So this is going to be 1 times negative 12. So our A times C just gives us negative 12. And now you're going to be good, hopefully. If you've done these already, you probably are good at it already. Is dividing this negative 12 up into factor pairs. These are called factor pairs. Things multiply times itself, it gives you negative 12. And I just go down the list. This is what I do. I do 1 times negative 12 is negative 12. 2 times negative 6, I just go 1, 2, 3, 4, 5, 6 if I can, times negative 6. And there it is again. Stop it. And then I would do 3 times negative 4. Come on now. There we go. That's better, I guess. Well, a little better. And what else do we have? Well, then we have negative 4 times positive 3. Sorry. Then we have things that are opposite. For example, we have negative 1 times positive 12. Negative 2 times positive 6, to get 12. Negative 3 times positive 4. And we're trying to find, believe it or not, all we got to do is that AC method, do our factor pairs, that's what these are, and find something that adds up to the middle term. Dang it, why is it doing that all the time? Well, it wouldn't be like an online virtual thing if you didn't have a technical glitch. So any of these add up to negative 1 that I have here so far? Yep, here it is. 3 minus 4. And this is it. Once I identify that, and this is the neat thing about this method, or this trinomial, if it has the lead coefficient of 1, you just write down the answer once you find the factor pair. Okay. So to recap, multiply A times C. If your lead coefficient is 1, find the factor pair that adds up to. It has to add up to the number, the coefficient of the middle term. So when I add them together, I have to get that, which it did. And so then just use these numbers as the constant terms in your binomial. And you're ready to rock and roll. One more. I know, as I said, this is kind of quick. And this was really a review of these things. And Amanda, I know right now you're really learning these. So if nothing else, it's going to be kind of a preview of some things that you're going to get experience in and do on your homework. I know you had a few questions maybe with factoring, those GCFs. So, all I can say is make an appointment if you need, if you want some more work with the tutor, or make an appointment with me. And I think mine's David, I think it's David P3. When you take a look in BrainFuse, you can find me there. But we really don't have enough time to do this very important trinomial justice. So I'm going to work it as an example and leave it at that. But just be aware, Amanda, I'm sure you'll have questions. This is by no means going to help you become a master of these in an hour. But let me leave you with this last one, just kind of as a thought. So here we go. Here's our trinomial, and at least you'll see somebody work through an example that has a lead coefficient other than 1. Notice the lead coefficient is 4 in this case. Okay. So that's my A, from the A, B, and C again. This would be my A. This would be my B, negative 25, and this would be my C. guess what we're going to do? We're going to do the same thing. Basically, we're going to take A times C. And we're going to start with that again. In this case, it's 4 times negative 21. Which in this case is negative 4, 25, and 21, 3, 4, 2, okay. Which is negative 84. Okay, that's a huge number. And this is a good example to look at because they're not always going to be easy and pretty. Sometimes you're going to get big numbers that you have to deal with. But I'm telling you, when you do your factor pairs, just do the simple 1, 2, 3, 4, 5 and just start dividing those numbers into it. So 1 times negative 48 or 84, sorry. And then I'm going to do 2 times, in other words, divide 2 into it. And I want to always keep an eye out for something that'll add up to negative 25. And I'm not there yet. I'm going to try something like maybe 3. Get my calculator out if I can't do it in my head. 3 goes into 8 one time, or 2 times. And 3, 8, 24. There's 1. And, oh, hey. Notice I can stop now because I found 2 numbers that add together to give me 25. So this factor pair method for AC works nicely. Unfortunately, with the lead coefficient other than 1, we have to do some more work. What we do is we break that middle term down into the things that add up into it. So I'm going to write minus 25 as 2 like terms. Negative 25x is the same as negative 28x plus 3x. I'm going to write down everything else that goes along with it. And now notice that I have 4 terms. And we practiced 4 terms. We broke it up into the first 2. And the last 2. And we found GCFs. So the GCF for the first term is going to be 4x, leaving with x minus 7. And if you look carefully at this, this looks like one we already did. For the second pair, 3x minus 21, a common factor is 3. Now, for these 2 big terms here, they've got a common binomial term, x minus 7. Notice it matches, so I must be doing something right. And once I get rid of those, I divide those out, what am I left with? My second binomial, 4x. Make sure you put it in parentheses, because we want a binomial times a binomial as our factor, our possible factor of this trinomial here. So if we take these 2 binomials and FOIL them together, they will multiply to give us that. So you can see factoring is just the reverse of multiplication. All right, Amanda, thank you for attending my workshop. I'm sorry it has to be over, but please, set up a tutoring session if you need more work, okay? Okay, bye now.
You are currently the only person in this conference.